Yeah, my talk is called The Human Factor in QA, Testing Beyond Code. A few words about me. If someone doesn't know me, I have quite a few years of experience. I love dogs and cats, and I have a blog and I have a LinkedIn. And this is what my partner thinks I am. So the talk is about the human factor and the bugs in processes. Why I came up with this talk? I recently moved to France, and if you are an immigrant, you look at the processes with a fresh eye. So you can apply for a visa, for a residence permit, you get your kids to the kindergarten, to school, to somewhere else, you get a driving license. And sometimes something feels a bit off, a bit weird. Something feels as if there is a bug in this process. Like you didn't expect certain peculiarities of the process. And I would say that this is somewhat resembling to QA work. Like if you join a new company, if you join a company, you see a product there, you start exploring this product, you start analyzing what's there. And this freshness of the eye gives you quite an interesting ability to test it better. And yeah, sometimes you find these creatures in the code. By the way, the origin of the word bug is quite interesting. I've researched this topic, and the first occurrence of the word bug is from 1800, so it is quite old. But in software development, this is the first document. It was 1947, and the electronic machine, the electronic computer, didn't work properly. And there was a post-mortem analysis, and they found this moth, this bug, and it says relay 70 panel F moth in relay. So this poor creature died, and it was short-circuiting the small relay. And they realized that something might cause the computer to malfunction sometimes, and it is quite strange. And this is why we call defects bugs now. But anyway, so what is a bug? I would say that a bug is when we see something is not working as we want. Like I've mentioned, processes, when you emigrate to a country, you have some dissatisfaction sometimes with certain processes. But you can't fix them because you have no control over them. So in immigration, we change our expectations. So we change, like in this phrase, we change we want. We don't change the process. We can't do that. At work, we came to the company to work to produce something of good quality. And if we find a bug in the code, we go and fix it. Well, sometimes product managers say, let's fix it later, but we tell them, no, we fix it now and we fix it. That's how I think we should work. Anyway, I believe that we also should fix bugs in processes. So what is a bug in a process? I think the same definition applies, that when the process gives us something like works in a way how we don't want it to work, I think it is a bug there. There is a bug. And in order to understand if there is a bug, we need first to understand what is it that we want from the process. And then we actually have to look at what the process is doing. And I have a few examples of certain process activities which I want to analyze from this perspective. First one is code freeze. How many of you deploy on Fridays? Pretty much everyone, but still some people don't. And it's quite a famous practice still, unfortunately. The incentive, the reason why this practice emerged is quite simple. We don't want to have bugs on production. We don't want the production to not be working during the weekends. And we don't want to be fixing the production during the weekends. We would rather have rest and recover from the week of work. So the intention is good. We want not to be bothered fixing something during the weekend, so we want some safety. We introduce code freeze. But then, and this topic is very well researched in software development management practices, is that there are a couple of bugs in these process activity. First, of course, it's slower releases. If we have some code which is waiting till Monday, this code, this feature could be benefiting users from Friday, but we don't release it. And second one, which is not that obvious, is that there is no incentive for us to improve the system, to install CI/CD, to make more auto tests, to work closer with manual QA engineers so that the code is always ready to be deployed to production. There is no incentive for us, no motivation for us to improve the quality of what we're doing, because we simply freeze the code and don't deploy it. So this is one example of a process activity. Another one is object relational mapping. It's not a process activity, it is a tool. How many of you use ORM in daily work? Okay, quite a few people. There is an interesting story about Stack Overflow. I think you all know the site. And Jeff Atwood and I forgot the name of the second guy. They were the engineers who were starting the product. And they were intentionally using the thinnest possible ORM, which was pretty much doing parameterized SQL queries, nothing more. What they said is that they knew the website would grow, and they wanted to face the complexity of writing SQL code when they were starting, so that every day they had to write some SQL code. Every day they were facing this complexity. And when we face certain complexity, we learn. We start to understand SQL better. So what is the problem of ORM? Well, the reason for emergence of ORM in the product is that we want to ease our work with the database. We rarely want to write SQL queries on our own. We want some library to do it for us. But I've seen products where the ORM as an abstraction started to leak when the complexity which ORM is hiding behind the library code starts to hit you in the eye or wherever. And sometimes it took people so much time to fix that complexity that some products, and I've seen 3 of them, in later stages of their development and life cycle, decided to move away from ORM, simply to remove ORM code and replace it with SQL parameterized queries, simply because they wanted at that stage to control how they work with database in a better way. And this is quite interesting. So they started developing slowly and slowly and slowly. The complexity of the database queries was hidden away from them. But then it hit, and when it hits like really, really hard. But at that time, no one on the team, pretty much no one on the team, knew how to write SQL queries and how to profile SQL queries, how to do analysis and everything else in the database client. So there was no incentive for people to learn SQL when it was easier. I think it might be a bug of this tool, a bug in a social way, in a human factor way. This is one of my favorite process activities. The reason for the code review is usually twofold. It's knowledge sharing. So whenever Andrei is writing code and he is passing the code for me to review, I am supposed to understand it. I'm supposed to learn it, at least somehow. I'm supposed to kind of feel it. So there should be some knowledge sharing. And second reason is obviously less issues with quality. So the supposed way for the code review to work would be so that if Andrei writes some code where I can see there is a defect, I tell Andrei, well, Andrei, please go and fix that defect. But with code review in a classical way, where Andrei sends me a pull request and I review it, there are a few bugs. First bug, and I call it a bug, is a delay. In many, many companies I've seen, if you take time to market metric, which is from the commitment time of development team to do certain feature, to the production, there is this lag of time where during this time there is development and testing and everything else. sometimes code review takes up to 30 or 40% of the whole time. Because if Andrei finishes work on his task and passes a pull request to me, I'm working on something else right now. So the task will wait for me to complete that task. Then I will switch to Andrei's task, review it, and come back. In some companies, and it's quite easy to check in Jira or anywhere else where you have statuses in your columns, in some companies, tasks wait for review for one and more days. So for any feature you're building or any bug fix you're applying, the code will wait. And the delays might be perceived as unintended consequences of this process activity. Second bug, well researched, is conflicts. There are multiple articles on the internet talking about how not to make code reviews toxic, how not to have conflicts in code reviews. So why is that? Well, essentially the reason, the psychology has to say a lot about this topic. When I'm crafting something from leather, let's say I craft a wallet, and I give it, let's say, to Andrei. Andrei says, "This is shit. Just get it redone." Well, I will be quite frustrated because I spent effort on doing this thing. Even if he thinks it is not of good quality, he might have put it in a different way. But anyway, I will perceive any criticism to any work where I spent effort as criticism. And I would start disliking this person. And I've seen during my experience so many conflicts in code review. Well, people argued and sometimes even shouted at each other. I believe this is another inevitable part of the code review process activity as it is, and which leads to conflicts, and it might be a bug. And also, this is quite interesting, even though one of the reasons for the code review practice is to share knowledge, pedagogy, the science of teaching kids, and andragogy, the science of teaching adults, they all say that the best outcome in learning is achieved when we do certain things together. Like if you go to boxing or wrestling or any other sport, first you're doing something with a coach. He shows it or she shows you what to do, you copy, and essentially you're learning much better if you are just following someone. In pair programming, knowledge sharing is the best according to multiple research. So why doesn't code review yield good learning outcomes? Well, there are a few reasons to that. First, if I am the developer, if I am developing a certain feature based on the user story, what I do, I create code based on my understanding of the requirements. Thanks, Anastasia, for bringing up the topic of requirements testing. So what happens? Even if I and Andrei are really well synchronized on what needs to be done, we might perceive the how very differently. He might write the code for the feature in one way, I might write the code for the feature in another way. So if I give Andrei the code for the feature, what he needs to do to review it properly is he needs to understand the requirements, compile it in his head, the code, and compare what he compiled in the head to what I gave to him. And we are comparing two take-home exercises. And at school, the results are usually quite similar if you're doing math or any other calculations. At work, we create code in a different way. So it's really hard to learn from each other when you're just reading someone else's code. And also, another peculiar bug of this process is that there is very little quality improvement from code reviews. This is easily tested in any company. If you just see during last month, take Jira and see how many fixes during code review, which were done during code review, actually improved quality. I've seen companies where they really agree within teams that only defects, only something which is not working is fixed during code review. And then everything else will be refactors later. But in many companies, I also see that people just fix random stuff. Like this could have been done in another way. Okay, so is it a quality issue? It's very hard to reason. Again, I'm not saying that code review is buggy for everyone. I'm just saying that these are areas that I know of that might be buggy, and maybe you should have a look at them. Another topic that we discussed, like Frank was giving a talk, was mentioning generating code. And I had this question. So what happens when we don't face complexity on doing something on a daily basis? If our intention was to write code easier so that we started writing code with AI, would we continue learning how to write code better? Maybe not. Maybe our learning will stall. Maybe we'll stop learning how to write code. Maybe not. Again, it depends on how people write code. But some people are lazy. It's a very low percentage of people who are lazy naturally. Many people are overloaded with work. And so when you are overloaded with work and you have a tool which seemingly nicely works for you, maybe you will rely on it too much because you want to have more free time. You want to spend more time on learning, studying something else. And so the more you rely on someone else writing the code for you, the more the manager you become, the less the developer you become. And also there is an interesting study on security. If you ask the AI to write the code for the feature for you, and imagine you have 800 lines of code, how likely is it that you will review the code for the security hole? It is quite hard to review 800 lines. And if you rely on AI, and it produces you good results most of the time, so you stop actually checking every single line. Like, why bother if it gives me good results? And after a certain amount of time, there are security issues. And there is a good study, I'll later give the link on LinkedIn, saying that the users of Copilot produce less secure code, which is quite obvious. And again, as I've mentioned, there is no incentive for learning. How I work with AI, where I think there is an incentive for learning, I write stuff myself, ask the AI to check it for errors, ask the AI to come up with better solutions to better alternatives to what I wrote. So I ask it to provide me the variety of options from which I can choose, but I do the writing myself. Sorry. And this is the most famous one, and this is so bad, I can't even imagine how bad it is. In certain companies, managers think that if we reward QA engineers for finding bugs, they will be better motivated and they will find more bugs. It sounds kind of obvious and kind of intuitive, but then it doesn't work that way. First, there is this thing called Goodhart Law, and the best story I've heard about it was from 18-something in India, when the UK was still ruling India. And the UK officials, British people, saw that there are so many snakes in the streets, lots of snakes, and British people don't like snakes. So they started rewarding with money Indians for snakes' heads. So if you're an Indian, you bring 10 heads to the UK official and you get some money. So Indians, being quite smart, they started farming snakes, and most snakes escaped. And of course, the streets were just, there were too many snakes then. So this incentive, monetary incentive for finding something, pretty much always destroys the system. This is called the Goodhart Law, which is phrased as when the measure becomes the target measure of something, bugs, snake heads, whatever, it stops being a good measure, a good target. It just stops. And another bug in this activity is conflicts. I've mentioned when I talked about code reviews that whenever there is some tension between people provoked by the process activity, like, you, Andrei, have to criticize my code. You have to find issues. You're incentivized to find issues. or you, Nastya, has to find bugs in my code. The more bugs you find, the more money you get. We will have conflicts. You will start, maybe not you, but people sometimes even irrationally start to do certain things which are quite strange. For example, with this particular process activity, what happens is that, well-studied area again, QAs start creating bugs for just one bug, multiple bugs for just one bug. So if you can put in Jira multiple tickets explaining the same bug in different words, you will start doing that. Most of people start doing that. And so whenever you see process like that, it's full of bugs. So I've shown you a few examples of processes where I either read research about that or I saw those unintended consequences or bugs. So what do? Of course, we can try to design processes with no bugs. This is like quality assurance. The whole concept of quality assurance is to prevent bugs from appearing. And the second concept is quality control. If bugs are found in our process later, we fix them. Designing processes with no bugs or less bugs is quite hard. It takes, and these are the areas of knowledge I have just studied, and not extensively. And so, for example, HCI, human-computer interface, or otherwise called ergonomics studies, they study how we operate with tools, with a computer, how our cognitive span works with computers, how much attention can we pay to certain activities. Like if you read a textbook on HCI, you will understand that it is almost impossible to expect a person to code review a task with 800 lines of code. The person will have to spend at least a couple of days to do that properly, and usually people don't have enough time to do that. Knowledge management, the whole andragogy, pedagogy, and everything there, it talks a lot about complexity and learning, when we should have complexity, when we shouldn't have complexity, how we learn, and etc. Organizational psychology talks a lot about teamwork conflicts, when the team is a team and when it is a group. It talks about conflicts and motivation. Total quality management, huge area, cross-disciplinary area, talks about how to create processes that will assure quality in your production. Toyota production system is based on TQM, and Kaizen is based on TQM. Anyway, it's a huge one. Decision-making theory, another area. It talks about this approach of taking and making proper, rational, and optimal decisions. Like when do we need to make certain decisions? Operations research talks about solving problems within companies, and queuing theory talks about, well, queues. Like if you tried writing Erlang code, you will have to study queuing theory to write it properly. But also it talks about synchronous and asynchronous work a lot. When we should work together, when we should work separately. So this whole area of knowledge is enormous. And I would say that designing processes with zero bugs is impossible. Humans bring uncertainty to any process. And we might realize that even if we spend like a year on designing good processes, we might find bugs in it later. So the other approach would be to, like quality control, especially to do. If we find a bug in a process, we fix it. Like many companies I know of have zero bug policy to the code. So when a bug is found, it is either fixed or considered not a bug. Quite a simple approach. Kaizen, the principle from total quality management, from all those Japanese companies which still dominate the market, like Toyota, like Sony, it was quite famous for good quality earlier. They have this approach called Kaizen. So the approach can be explained very simply. If you find something is broken on the floor, you stop and fix it. If you find something is broken in your colleague's code or computer, you sit together and fix it. So whenever anything is found which stops you from doing the right work in a proper way, you fix it. But in many companies, Kaizen, I would say, cannot be implemented because not all managers understand the value of quality, unfortunately. And most managers expect you, the developer, or you, the QA, to do the feature you are told to do. And so if, let's say, you spend 2 days on a feature and then found out that some process activity is buggy, you come to the product manager and say, we want to stop working on this feature for a couple of weeks. We need to change our process. Well, I guess they will say, no, not really. Maybe sometime later. Maybe let's discuss it later. So there is another approach, much easier one. Scrum folks, when they design Scrum, they realize that processes might have bugs, and processes or impediments, how they call it, might come up during our work. And so they introduced the concept of retrospective. The only problem I have with the retrospective in Scrum is that it is still Scrum and that you shouldn't at least change Scrum. Well, currently they changed it in the last Scrum guide. They said that Scrum can be changed. Before that, they said Scrum was immutable, if I remember correctly. But anyway, retros are the good place to discuss process activities. And I suggest that during retros, you also discuss things like, do we need daily stand-ups? Or do we need code reviews? And this might be hard, but I think it's quite interesting. And there are certain prerequisites in the corporate culture which are required for you to be able to change processes and find bugs in them. First, you want to desire it. First, you want to dislike when certain things are misbehaving in your processes. Second, you need honesty. If you are not honest with your team, and not all team members are honest, they will not give you their opinions properly. They will not tell you, I dislike code review. They will not tell you that I think we're wasting our time with doing estimates, or I think we're wasting our time doing something else, or I think I'm fed up with conflicts in our something. Third thing, you need time. Well, if you have retrospective, you have pre-planned time for this activity. If you have Kaizen, you need managers to agree on spending time on improving process. You need empathy. If Andrei tells me, Vitaly, I'm really disliking certain process, in order to be able to find a bug in a process, fix it, I must feel empathetic towards Andrei, and I must actually try to understand what he is saying. And we need critical thinking. I would say that 0 process activities are mandated. I would say that we can question everything. And some process activities have more value than bugs. Some might have more bugs than value. And we need knowledge. So I suggest you still read something from that, and I will give lots of links later. And a very good approach, which worked for me in a few companies, is organizing quality circles. And quality circle is a group of people who want to improve the company, who want to improve what's going on in the company. And it might be pretty much anything from retention. Let's say people leave your company too often. If you have a quality circle, and everyone is invited to the quality circle, like engineers, QAs, managers, HRs, whoever, you will have time, like every Friday you gather and discuss problems, and you say, all right, I think we're losing people way too much. And if everyone agrees with that, you might raise this problem to the management. And yes, support from management is needed. If quality circle is just another retro where nothing is fixed after the retro, there is no value in that process. And I call this talk human factor, because I believe that everything is about people. And I believe that the worst bugs in our processes, the worst inefficiencies in our processes are not about code, are about how people work together. If they collaborate or not, if they just execute what they're told to, or if they question or provide alternatives. And unfortunately, most managers lack knowledge on how people behave and how people work together. But you might become a manager someday. I don't recommend, but you might. Because when you are a team lead or a head of a department, you have pressure from both sides. When you are just a developer or QA engineer, you have pressure from just the top, usually. It's harder to work when you have pressure from both sides, and many managers, unfortunately, will start treating people like machines, especially if they have many. And I believe that this is the worst bug in our companies, when we start treating people like machines. I think we must acknowledge people for their beauty and their messiness. And do we want bugs? I don't. Maybe you do. Who knows? Thank you. Questions?